Hey guys, Mr. Betts here. I want to go through a few examples where I am integrating using substitution, and specifically I want to look at some definite integrals. So I'm going to go kind of rapid fire here and talk through the process of how I'm choosing my u and then look at what the workflow is going to look like. So in this case, I want to simplify my integrand here by letting u equal y plus 1. And what that's going to do is it's going to allow me to write this as u to the 1/2 power, and then go from there. This is a pretty straightforward substitution because du is equal to dy, so I can just replace the dy there. So this is going to equal the square root of u, so the integral of the square root of u, which I'm going to write as u to the 1/2 du. And then since I changed the dy to du, remember we have to change our limits also. So if y is 1, u is going to be 1 plus 1, which is going to be 2. So my lower limit is going to be 2. And then the upper limit is going to be 3 plus 1, which is going to be 4. So then we take the antiderivative. So we get u to the 3/2, and then we're going to multiply by 2/3. So divide by the new exponent, which is multiplying by the reciprocal, evaluating that from 2 to 4. So it's going to be 2/3 times 4 to the 3/2 minus 2 to the 3/2. I want you to notice that I factored the 2/3 out here, which is acceptable, or you could put the 2/3 on both terms. Either way is okay. And really, this numeric answer is acceptable. You don't have to go further. I do want to point out that this is going to be a radical here, that 2 to the 3/2 power. However, the 4 to the 3/2 power is something you should be able to evaluate at minimum to be able to match a multiple choice question. So if we're evaluating 4 to the 3/2, remember that's the square root, the 2 on the bottom, and then a cube. So the square root of 4 is 2, and then 2 cubed is 8. So if you were simplifying that 4 to the 3/2 would be 8. Next example here, as a general rule, if we have a fraction using substitution, usually letting the denominator equal u is going to make things simpler for us. So I'm going to say u equals e to the x, and so du is going to be e to the x times dx. And notice that the derivative here involves this e to the x here, which is going to work out well for us. I'll solve this for dx and get du over e to the x. So making my substitution, I'm going to have u in the denominator. I'm going to have e to the x stay there, and then dx is going to become du over e to the x. So again, the dx is getting replaced with that. And then since I changed the dx to du, these limits need to change. Those are x values. If we plug those in for x, then the natural log of 2, let's do that one first. So if we plug natural log of 2 in here for x, we have 1 plus e to the natural log of 2. Remember, the exponential function and the natural log function are inverses of each other, so that's just going to be 2. So that's going to be 1 plus 2, which is 3. And then our upper limit is going to be 1 plus e to the natural log of 8, which is 1 plus 8, or 9. We can simplify the e to the x's here. Those are going to go away. So we have the integral from 3 to 9 of 1 over u du. Now, what do we take the derivative of to get 1 over u? That's going to be the natural log of the absolute value of u. We absolutely need to have that absolute value there. It's very important when we're taking the antiderivative of 1 over u. And then we're evaluating that from 3 to 9. So that's going to be the natural log of 9 minus the natural log of 3. Again, this is a numeric answer that we could box. Remember log rules, we can do this as a natural log of 9 over 3, which is natural log of 3. Definitely a simpler way to write it. Either one and free response would be okay. This one here, since we have a cosine squared, I'm going to let u equal cosine. That way the cosine squared is, just cosine. That way the cosine squared will become u squared, and the derivative here is going to be the opposite of sine of theta d theta. So d theta is going to equal du over opposite of sine of theta. So making our substitution, we have the integral of 3 sine of theta u squared, and then d theta becomes du over negative sine of theta. And I also need to change my limits at this point. So when theta is pi over 6, cosine of pi over 6 is going to be square root of 3 over 2. And cosine of pi over 3 is going to be 1 over 2. And we can simplify the signs. So sine of theta cancels with sine of theta. That negative can go with the 3 and go out front. So this is going to be negative 3 times the integral from square root of 3 over 2 to 1/2 of u squared du. All right, so now we evaluate the antiderivative using the power rule this time. Power rule, we're going to get u cubed over 3, and that 3 is already out front, so the 3's go away. And that's just going to be u cubed, and we have that negative still, and that's being evaluated from the square root of 3 over 2 to 1/2. So we have negative 1/2 cubed minus negative square root of 3 over 2 cubed. And that's acceptable. You could do some arithmetic to do some simplifying there, but it is not necessary on a free response question. This one, we've actually got a couple of pretty good options. I'm gonna look at both of them, and then I'm gonna choose one. So if we say u equals tangent of theta, then du is going to be secant squared of theta, and that's going to take care of this. If we let u equal secant of theta, then du is going to be secant of theta times tangent of theta, and we're going to get, with the secant there, we're going to have secant times tangent, and that's going to take care of the derivative there. So either one of those is going to be a nice clean substitution. So I'm going to say u equals tangent of theta. But if we say u equals secant of theta, this should also work. I do want to point out that if we choose secant of theta for u, we're not going to make this u squared. We're going to make this u because we want to keep that secant in there for the derivative part of it. So du, with u being tangent, du is going to be secant squared of theta, d theta. So d theta is going to be du over secant squared of theta. So making our substitution here, tangent is going to become u. Secant squared of theta stays there. D theta becomes du over secant squared of theta. And notice the secant squareds are going to cancel out. But also we need to change our limits. So tangent of negative pi over 4. So pi over 4, tangent of pi over 4, that's a 45-degree angle, is 1 over 1. In the fourth quadrant, tangent is negative, so that's going to be a negative 1. And then tangent of 0 is 0. So simplifying this, secant squareds cancel each other out. So we have the integral from negative 1 to 0 of u du. Then we take the antiderivative. So that's going to be u squared over 2. That's the antiderivative of u. We're evaluating that from negative 1 to 0. Plug 0 in. Plug negative 1 in. And we get negative 1/2. Okay, on this one, when I choose my u, what I'm going to try to do is simplify the square root part here. So to do that, I'm going to let u equal the inside of the square root, the radicand. So u equals 1 plus x cubed. And the derivative of that is going to be an x squared, which is going to take care of that. So du is going to be 3x squared dx. So that gives us dx is equal to du over 3x squared. So that x squared in the denominator is going to cancel out with that x squared there. So we have, for now we're keeping the x squared in there. I'm going to write this as u to the 1/2. And then instead of dx, we're going to have du over 3x squared. And then remember our limits, the 0 and 2 are x values, so we need to change them to u values. When x is 0, u is going to be 1. And when x is 2, we have u is going to be 9. Doing a little simplifying here. X squareds cancel each other out. That 1/3 can go out front. So we have the integral from 1 to 9 of u to the 1/2 du. Antiderivative of u to the 1/2 is going to be u to the 3/2 times 2/3. And we have the 1/3 that's already out there. And we're evaluating that from 1 to 9. So we have 2/9 times 9 to the 3/2 minus 1 to the 3/2. Again, notice that I factored out that 2/9. It's being multiplied in both terms, but we don't have to have it in both terms. This is a numeric answer that would be okay to stop. I do think that it's good to practice with simplifying just because you might have to do it for a multiple choice question. 9 to the 3/2, square root of 9 is 3, and then cubed is 27. So we're going to have 2/9 times 27 minus 1, which gives us 52. So 26 times 2 is 52 over 9. If this were a multiple choice question, 52 over 9 would be the option you're looking for. Last example I'm going to do. This time I'm not going to let the whole denominator be my u. And the reason is that's going to be an r to the 4th power, and the derivative of that would be an r to the 3rd power. And we don't have an r to the 3rd power here. However, what I can do is let the inside of the square be u. So I'm going to say u equals 4 plus r squared. That's going to have give us a u squared in the denominator, but also the derivative then is going to have an r to the 1st power in it, which is going to help us take care of that. So we get dr is equal to du over 2r. And so making the substitution here, we're going to have integral 5r stays on top for now, u squared on the bottom. Dr becomes du over 2r. Simplifying what we can. Actually, sorry, we need to take care of our limits. If r is 0, u is going to be 4. If r is 1, u is going to be 5. Now we simplify. So r's cancel. The 5/2 I'm going to take out front. So we have 5/2 times the integral from 4 to 5 of u to the negative 2 du. So I wrote the 1 over u squared as u to the negative 2 because I can use the power rule on that. So we get the 5/2 stays. We're going to have u to the negative 1. So we increase the power by 1. Then we're going to divide by the new power. So we divide by negative 1 and we get negative 5/2 u to the negative 1. Or we could write it as negative 5 over 2u, evaluated from 4 to 5. So that's going to be negative 5 over 2 times 5 minus negative 4 over 2 times. Sorry, that should be a negative 5 on top. So that's going to be negative 1/2 plus 5/8. So that looks like it's going to be 1/8 as our simplified answer. But again, once we get a numeric answer here, that would be acceptable.